Correlation example 2. In this example, we're going to be calculating some of the quantities that build up towards giving us a correlation coefficient. These are called SXX, SYY, and SXY. Above example 2 in your notes, there's two versions of the formulae, and we are going to use the second version, so make sure you highlight it. I put a big box around it. The one we're going to use is this. And so we need to work out each of these quantities. Now you'll remember these from working out the variance earlier on in the course. So sigma x, you should know, means just add up all those x values. And if you add them up, you get 1077. Sigma x squared, from working out the variance, you should know, hopefully, that we square them first, then add them up. So you would do 167 squared plus 185 squared, and so on. So have a go at doing that now. Pause the video. And if you pause the video and had a go, I hope you got 194657. We also need to know n. N is 6. That's the number of items of data. It's not 12. Each courgette had 2 measurements associated with it. So the number of courgettes is 6, 2 measurements associated with each. That's why we've got 12 numbers. So we'll substitute those in now. 194657 minus 1077 squared divided by 6. Work this bit out first. Subtract it from the previous value. Pause the video to have a go. And you should have got 1335.5. If you didn't get that, have another go. Make sure you get that correct, because the keystrokes, the order in which you press the keys on the calculator, is really important for that. So very similar for SYY. Same idea. So sum of y squared we're going to have to work out. Again, square each one first and add them up. 36 squared, add 38 squared, and so on. If you have a go, you should get 7402. So make sure you check that you can get that. We also need sigma y. That just means add up the individual y values. I got 210 for that one. So substitute them in. 7402, that's not a 6, that's just my writing. Subtract 210 squared of 6. Again, work out this part first, then subtract it. And if you have a go, you should have got 52. Last one, SXY. Instead of having an x squared or a y squared, we have one of each, so it's x times y. And then on the top here, we have the sum of x, sum of y over n. So let's have a look at this one. The first quantity, sum of xy, means you multiply each x by the corresponding y and then add them up. So 167 times 36. Work that out. 185 add 38. And you can do this in brackets as you go along. So put that in brackets, add, multiply these two in brackets, add, multiplying those two in brackets, and so on. And if you do that, sigma xy, I got 37841. So check if you get that. So we get 37841. The sum of x we've already worked out is 1077. Sum of y we've already worked out, that was 210. Again, work this big fraction out first, then subtract it, and you should get 146. Later on, when we come to do the actual correlation coefficient, the formula you'll see later in your notes is this. So what you could do now is actually have a go, even though it doesn't ask us to. 146 on the top, and then on the bottom we'd have 1335.5 times 52. Multiply these two together, square root it, and then divide 146 by your answer. I had a quick go at doing this, and I got 0.554. What that actually means we'll come to when we look at the next example.